Right now, we'll be talking about arithmetic series. An arithmetic series is defined to be the sum of all terms of an arithmetic sequence. Take note, an arithmetic sequence is different from an arithmetic series. A series refers to the total, while a sequence is talking about patterns. So as defined by arithmetic series is known as the sum of all terms. Okay, so let's have the formula of an arithmetic series. We have this formula. S sub n is equal to n all over 2 multiplied by 2a. This is actually 2a sub 1 plus the difference of n and 1 multiplied by d. Okay, we are not going to use your a sub n because this is not a sequence. This is a series. So we have here s sub n, which means to say the sum of the given series. Then we have here your n. This is the position of the term that will be added up. Then we have your a sub 1. A sub 1 here is your first term. Okay? Then we have your d, of course. Your d is your common difference. Let's have an example. Let's say we have here, we have your 9, 18, 27, 36, 45, and so on and so forth. As you can see, this is an arithmetic sequence. It is a sequence because they have a difference between and among the different terms. Their common difference is equivalent to 9. So, this is also known as arithmetic sequence. Just like what I told you last time, that an arithmetic sequence is defined by getting the following terms or the succeeding terms by adding a constant, and that constant is the common difference. Now, the question is, we are going to find out the series of this sequence. We are going to find out the sum of the first 100 terms of this arithmetic sequence. So we have 9, 18, 27, 36, 45. Now, we are going to find out what is the sum of the first 100 terms of this arithmetic sequence. Okay, by using the formula as stated above, we have here your a sub 1. Your a sub 1 is definitely equal to 9. Then our common difference, which is denoted by d. Again, our d is defined by this simple formula, getting the difference between a sub 2 and a sub 1. So let us find out first your common difference. So our second term, what is our second term? Yes, it is 18. How about our first term? Yes, it is 9. So 18 minus 9, our d now is equal to 9. Okay. Now, we are simply going to substitute the corresponding values of the variables using our main formula. Remember that this formula will only be applied if a sub n is not given or identified. If your a sub n is not given, then you are going to use this formula. Always remember that. In our example 1, our a sub 100 is not given because we only have here your first 5 terms, right? Because we have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and so on and so forth. So to determine the value of the arithmetic series of this arithmetic sequence, you need to identify using your a sub 100. But that would be another formula which will be discussed later on. So here, let's go back. If a sub n is not given, what should we use? Of course, we'll be using this formula. Okay, now let us solve. So the series of this arithmetic sequence would be s sub 100 because we are looking for the value of the first 100, the sum of the first 100 terms of this arithmetic sequence. So s sub 100 is equal to, of course, our n is equal to 100. So 100 divided by 2. Your 2 here is given by the main formula. You cannot change that. Then we have 2a sub 1. So we have 2 together with 2 here. You cannot change that. That's given. Times, what is our a sub 1? It's 9. Of course. Plus, we have here, again, your n is 100. 100 minus 1. Our common difference is equal to 9, of course. Now, let us simplify. S sub 100 is equal to 100 divided by 2 is equal to 50. Then, by using our MDAS, remember, using MDAS. So, 2 times 9, we have 18. Plus, 100 minus 1, it's equal to 99. Multiplied by 9. Okay. Now, S sub 100 is equal to 50 multiplied by the sum of 18 plus what is now the product of 99 times 9. 99 times 9 is equal to, what do you think? It's 891. Okay? Now, let us simplify further. So, we have 50 times 891 plus 18 is equal to, what is the sum of 18 and 891? We have 909. Now, let us get the product of 50 and 909. The product would be 45,450. This is now the answer. So, if we are going to find out now the series of our example using this 9, 18, 27, 36, 45, the sum of the first 100 terms, which is denoted by this, is equal to 45,450. This is the answer. So if you're going to get the sum of 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, until you reach your 100 term, that is equal to 45,450. Okay? Let's go to our next formula. Our next formula would be this one. As what I was telling you a while ago, our second formula would be denoted by this. S sub n is equal to n all over 2 times a sub 1 plus a sub n. Okay. So now, we are going to use this formula if a sub n is identified or given. Remember that our a sub n is our last term. This is our last term. So, let us use the same example. We'll be using this. We are still going to find out our S sub 100. Okay. So now, but first, we have to find out our A sub 100 because we still do not know. And using A sub n is important in this formula. So, A sub n is equal to A sub 1 plus n minus 1 times d. As you can recall, this is now the formula of an arithmetic sequence. This is the formula for arithmetic sequence. This is not an arithmetic series because we are going to look for your a sub n. Take note, this formula will be applied if a sub n is given. But in our example, a sub n is not given. We have to find out your a sub 100 so that we can simply substitute it here. So now let us identify a sub 100. We'll be using the same example. So a sub 100 is equal to, what's our a sub 1? Of course, it's equal to 9. 9 plus 100 minus 1 times 9. That's our common difference. Then we have here 9 plus 99 times 9. Then a sub 100 is equal to 9 plus 99 times 9 is 891. Correct? So we have here 99 times 9 is equal to 899. Then a sub 100 is equal to 900. Now let us use the formula here. So our 100 term is equal to 900. Now let us use this formula. Your 900 here is your a sub n. So we are going to apply our second formula. Now we have s sub 100 is equal to n over 2. We have 100 all over 2 times a sub 1 is 9 plus 900. Okay? Because our a sub n, which is our a sub 100, is equal to 900. So this will be substituted in the second formula if a sub n is given. Okay? But take note, to use this formula, you need to look for your a sub n. Okay? Or knowing your last term. So let us solve. S sub 100 is equal to 50. Why 50? Because 100 divided by 2 is equal to 50 times the sum of 9 and 900, it's 909. Then, if you are going to find out now the product between 909 and 50, it is also equal to 45,450. As you can see, using the second formula and using the first formula, we will still be getting the same answers. So from our first formula, we got 45,450. And using our second formula, we still got 45,450. So they are just the same. I hope you understood the lesson. Thank you.